In this video clip, we're going to continue talking about solutions, and in particular, what we're going to start off with is how do you make solutions? And in how you make solutions, we'll also talk about a process called dilution. So let's just start out with making simple solutions, and then we'll go to the dilution problems, which are a little bit more involved, but I don't think they're too bad. So let's just start out with some problems. We already know a few different concentrations for concentration units for solutions. So you could have percent concentrations, mass to mass. You could have percent concentrations, mass to volume, volume to volume, and you can have molarity. There's others, but those are the ones that we're going to stick with for now. So if we were starting out and I asked you, how would you prepare 100 grams of a 12% sugar solution? To answer this question, you need to go, I should say 12% mass to mass, right? How would you prepare 100 grams of a 12% mass to mass sugar solution? So starting out, what exactly is the formula for percent mass to mass? This is going to be the number of grams of solute divided by the number of grams of solution times 100. So you need the formula, of course, if you're going to solve this. So what exactly is given to us? The concentration is given. Concentration we want is 12%. And also what's given right here is the volume, the number of grams of solution is also given at 100 grams. And so in this formula, we basically have three variables, right? The three variables are our concentration, our grams of solute, and our grams of solution. And in this particular problem, we're given the concentration and we're given the grams of solution. And so what we're going to need to look for or solve for is the number of grams of solute needed. So we're going to have 12% is equal to X over 100 grams times 100. It's pretty easy math. Hundreds cancel and you're going to get X equals 12. Now the units on these, you have to put the units on each side to stay straight. So you could say 12% is 12 grams of sugar divided by 100 grams of solution. And then you could say is equal to X grams sugar divided by 100 grams, right, of solution. And so the units will work that way if you want to keep track. Lots of times when you see solutions of percent that worked out problems for solutions, they tend to not leave units in them for some reason, but it's good to keep track. So that's not really the answer. That just tells me how many grams of solute I need, but the question says, how would you make it? So how would you actually make the solution? So you would have to add 12 grams of sugar to what? What would you add it to? So the answer is not to 100 grams of water, because remember that the 100 grams is the total number of grams of the solution. So we don't have the solution, we have the solute and the solvent. So to get 100 grams of solution, and we now we have to have 12 grams of sugar. What that means is we would have to have 88 grams of water. So what we would do is we'd add 12 grams of sugar to 88 grams of water and mix. And that's how you would make the solution. The total mass would have to be 100 grams, not 100 grams of water. Now that's kind of tricky. You got to keep track of the units, because watch what happens in the next problem. In the next problem, we're going to just change the percent unit a bit. So what if now I asked you, how would you prepare 100 milliliters of a 12% mass to volume sugar solution? Now notice one thing has changed. Well, two things has changed compared to the last problem. The first thing is that I'm given a volume of solution, where in the previous problem I was given a mass of solution. And notice that this is mass to volume now, and before it was mass to mass. So in order to solve this problem, we need to know what is the formula for figuring out mass to volume, and the percentage mass to volume is equal to the number of grams of solute divided by the number of milliliters of solution times 100. So again, what do we know? In the problem, we have our volume of solution is equal to 100 milliliters. And we know our concentration is equal to 12%. So again, looking at our formula, we know this and we know this, right? We know these two things, and we're going to have to solve for grams of solute. So to solve for grams of solute, what you're going to do is say 12% or 12 grams of sugar divided by 100 milliliters of solution, right? That's what the 12% really means, is equal to X grams of solute, or sugar, which is our solute. And we need to also make 100 milliliters. So again, the math is, oh, I added a sig fig. Again, the math for this one is pretty straightforward because it's per 100 and we're making 100. So we would need 12 grams of sugar, which is the same as in the previous problem. If we needed to make 200 mils, if we were making 200 mils, then over here we'd put 200 and our answer would come out to be 24 grams, right? So if we were going to finish this problem off, because that's not the whole answer. The answer says, how would you make it? And this answer just says 12 grams of sugar. Somebody said, how do you make something? And all you answered was 12 grams of sugar. That's not going to help them out. Now this one's more tricky because the volumes are not additive. Masses are additive, but volumes are not, which means you can't say that 10 milliliters of one thing plus 10 milliliters of another thing always comes out to be 20 milliliters. It doesn't work. They sometimes get more dense or less dense and the volume changes. So how would you actually make this? You'd have to use a piece of glassware called a volumetric flask. You're going to see this in the lab this week. You're going to practice and they'll show you, and I actually put videos up where you can watch people making solutions. I'm not a very good artist, so I apologize, but the volumetric flask usually has a very long neck and then a bulb along the bottom. And what's true is there's a line somewhere on the neck of the flask, and that line at the flask is where you want to fill to. The line is in different places in different volumetric flasks. So, and volumetric flasks come in very specific sizes. So you can get an exactly 100 milliliter or an exactly 250 milliliter or an exactly 500 milliliter flask. You could not make an odd amount of solution in this. There is no flask to make 475 mils of solution. You have to make them in these quantities that volumetric flasks come in. So how would I do this? I would add 12 grams of sugar to the flask and add some water. So I'd put the sugar in here, and then I would add some water to get it to dissolve, and then, you know, stir it around, shake it, swirl it. And then after all of the sugar had dissolved, I would go ahead and add more water until my meniscus came right on that line. And so when you're making a solution, you have to really be careful, because if when you're adding the water, you actually overshoot that line, you're in trouble. So if here's the neck of my flask and here's the line, and I'm adding water into it and I accidentally put water all the way up to here, I have to start over again. There's no way to get that extra water out, not knowing that it's still pure water, because maybe some of the sugar's already in there. So making a solution, watch the videos. They show you the exact detail of doing this. And so our answer would be The complete answer would be add 12 grams of sugar to the flask and add some water, swirl, then add water to the line on the volumetric flask. And again, there's lots of videos posted this week in the lab for you to practice or see more detail of this. Okay, we'll do one more before we move on to dilutions. Last one I would have for you is how would you prepare 0.50 liters of a 0.56 molar sugar solution? Now in this case, we have molarity. And so the formula for molarity stands for number of moles of solute per liter of solution. So I have to use moles. And if I have to use moles, I'm going to need to know what is the formula for sugar. Sugar is C6H12O6. So if we have, well, that's glucose anyway. If we were going to go through this problem, then what you need to do is figure out moles. And so we're going to have to end up using the molar mass somewhere along the line. What's given to us in our problem, we're told right here we have the volume of solution. That's equal to 0.50 liters. And we also know the concentration of the solution. That's equal to 0.56 molar. So again, looking at this thing, in this equation, we're given molarity and we're given our number of liters of solution. What we're going to need to solve for this time is going to come out to be moles of solute. In the previous problems, we directly got to grams of solute, but that's not going to be the case here. So let's plug in to our equation and solve for moles of solute. I'm going to have 0.56 moles per liter, that's my concentration, is equal to X over 0.50 liters. Right, so solving for X is going to be equal to 0.56 moles per liter times 0.50 liters. Liters will cancel. We're going to end up getting moles. It's going to be 0.28 moles of C6H12O6. So knowing moles is great, but you can't measure in moles, you have to measure in grams. So we're going to have to convert moles to grams. So we need the molar mass of C6H12O6. So we're going to have 12 times 6 for the carbon. We're going to have for the hydrogen, oh, I should do it the other way around. 6 carbons times 12 each. For the hydrogens, we have 12 of them times 1. And for the oxygen, we have 6 of them times 16. If you add that all up, you should get 180 grams per mole. So I'm going to use that molar mass to convert my 2.8 moles of C6H12O6 times 1 mole. So 180 grams. And calculating that out, I get 50.4 grams. So again, this is just telling me my amount of solute that I need. It's not really telling me how do I make the solution. I would again, since this is volume of solution, I would need a volumetric flask. So I would use a 500 milliliter volumetric flask because I'm making 500 milliliters or 0.5 liters of solution. I would add 50.4 grams of sugar, add some water, swirl till it dissolves, and then fill flask until meniscus is on the line. So I would, again, I'd add my sugar, right? Then I would go ahead and add some water, get it to dissolve, and then I'd pay attention to where my line is, and I would ultimately fill my flask up with water. Oops, I meant to be in purple. Fill my flask up with water so that my solution, my meniscus, came right on that line. So those are how you would make solutions if you started with pure solute. Lots of times that's not the case. Lots of times in the lab, you start with what's called a stock solution. And a stock solution is a pre-made solution, typically with a high concentration. And you use that higher concentration solution to make lower concentration solutions. And so some examples, or the formula you're going to see in your textbook probably is M1V1 is equal to M2V2. I like to use a more generic version where I say C1V1 is equal to C2V2. What is M? Molarity. Volume, right? And what happens if I take molarity and multiply it by volume? Remember, molarity is moles per liter, and volume would be in liters. This would be equal to the number of moles of solute. And so basically what this is saying is if you know the number of moles of solute in a concentrated solution, and then you add more solvent, the number of moles of solute doesn't change, just the concentration of the solution changes. To show you that in more detail, say we had this big flask, and let's just pretend that this had 1 liter of solution in it right now. And in that solution, I'm just going to try to draw it really simplistically. Let's just say we had five things of solute in there. We could pretend each dot represents a mole of solute if you wanted to. So we would have in here 5 moles per liter, right? So our molarity would be 5 molar. Now, what if I diluted it? Diluting means adding more solvent, not more solution, you're just adding more solvent. So what if in this solution, I just added more water? If I add more water, my volume is now going to be up here. And so what's true is how many moles of solute do I still have in there? I still have 5 moles of solute. But what if I added a 2nd liter of water, but now have 2 liters of solution? And so my molarity is not going to be 5 anymore. I still have 5 moles of solute, but I now have 2 liters of solution. My molarity has now been diluted from 5 to 2.5 by adding more solvent. So what happens is if you take molarity times volume, you'll always get the number of moles of solute. And if you just are adding more solvent, you never really change the number of moles of solute, but you will change the concentration. Now your textbook goes through this using just molarity, but the truth is you can do this with any units of solution concentrations. That's why I gave you the generic C1 and C2. They just have to be the same unit. You can't dilute molarity into percent. You can't dilute percent mass to mass into percent mass to volume. So whatever concentration units you use in one side of the equation, you must have the exact same concentration units on the other side of the equation, but this will work for any units. So let's just try a problem. Let me get rid of red. If you had 68.75 milliliters of a 12 molar HCl solution, if the 6 is diluted to 1,000 milliliters, what is the new concentration? Now, one thing you have to be careful of. Oh, I'm just going to change this. Oh no, well, I'm all right. One thing that you need to watch out for is units for volume. They don't matter either as long as they're the same. So if this is milliliters and this is milliliters, I don't have to convert into liters. I can just leave it because they're going to end up canceling out. If one is in milliliters, the other one has to be in milliliters. If one is in liters, then the other has to be in liters. Otherwise the units won't cancel. So I'm going to have in my equation now C1V1 is equal to C2V2. And what do I know? I'm given a volume of 68.75 milliliters when my concentration is 12 molar. These are at the same time, so I'm going to give them both ones. V2 is now given to me as 1,000 milliliters. And C2 is what I'm asked for. So I just need to solve this for C2. C2 is going to be equal to C1V1 divided by V2. So plug in values. 68.75. Oops, that's not my first value. My first concentration, 12.00 molar, times my volume, 68.75 milliliters, divided by my second volume, 1,000 milliliters. Notice milliliters cancels, so you don't have to go to liters. It will just cancel out. What unit will I end up with? Molarity, because I started with molarity. And if I stick to 4 sig figs, I would get 0.8250. So these equations, you're always going to use C1V1 and C2V2. You just need to be careful that the units here are the same, and whatever units you have here are the units you're going to end up with in your end. But it doesn't matter what the units are as long as they are the same units for volume, same units for concentration. One other type of problem you could have to do this is, say you are making a solution by doing a dilution. I know that sounds odd. So what if I asked you, how would you prepare 250 milliliters of a 1.25 molar sodium fluoride solution if you started with an 8 molar NaF stock solution? So this is a dilution problem, right? And so what values do we know? We know we have a volume of 250 milliliters when we have a concentration 1.25 molar. Those are at the same time. Right? That's what we want to get. What else is given to us? We're starting with a concentration of 8.00 molar. And what we need to figure out is what volume would we need of that? Right? So notice this is more concentrated. And this is less concentrated. So in the end, what we're going to end up doing is adding solvent to the more concentrated solution. We're going to dilute it. So how much of this more concentrated solution do I need to start with? Well, I can use my equation. C1V1 is equal to C2V2. In this case, what I'm going to be solving for is V2. Also, it doesn't really matter if I call these ones and these twos, as long as I keep 250 with 1.25. I could have made these the twos and these the ones. It really doesn't matter. Some people always make the more concentrated ones with the ones, but it doesn't matter. So what am I going to get? V2 is going to be equal to C1V1 over C2. So I'm going to have C1, 1.25 molar, V1, 250 milliliters, divided by C2, 8.00 molar. Notice molar cancels out, and my answer is going to come out in milliliters. What do I have here? I have 3 sig figs, so I think this comes out to be 39.1 milliliters. So this is not my full answer. That just tells me how much of the stock solution I need. So to actually make this solution, I'm going to need to measure 39.1 milliliters of the 8 molar NaF solution and add it to a 250 milliliter volumetric flask. Then add some water, swirl, and then fill to the line on the volumetric flask. So this is really the answer to my question. I know these are kind of longer problems, and you'll see when you go through the lab this week, a lot of the lab is focused on you actually seeing this happen. So hopefully it will make a little bit more sense as you go through it. I'm gonna stop this video there and do a third part just so that this isn't ridiculously long.